Welcome back, everybody, to another video lecture from Mrs. Semino. Today, we're going to be in our fourth video, and we're going to be talking about molecular naming and formula writing. And then you guys, after the last couple lectures we did, you're going to find this one like so nice and easy. You're going to be so happy after this lesson. So let's look at this one. So molecular naming, just as a review, we kind of saw this like in the very first notes. Molecular compounds have only non-metals in them, and they have covalent bonds between them. When we talked about ionic compounds are made up of metals and non-metals, and they have ionic bonds, okay? So these only have non-metals, and these have covalent bonds, okay? So that's one way that you could recognize the formulas. So let me just give a quick little example here. So if you had like NaCl, you'd be like, oh, that's a metal. And then if you had this one here, like H2O, you know that those are both nonmetals. And so this would be our molecular compound here. Okay. Another way to recognize molecular compounds is by their names. So let's say they didn't give their formula, but if I said carbon dioxide, everybody pretty much knows how to write the formula for this one. This would be CO2, but do you see how there's this prefix in here, di? We did not use any prefixes when we did the the ionic compounds, but now we will. So this is another clue that it would be a molecular compound is if you see the dioxides. And as I go through here, I believe you're going to want to write these down. So mono means one, di means two, tri three, tetra four, penta five, hexa six, hepta seven, octa eight, nona nine, and deca is 10. So these are the prefixes that you're going to see us use when we write these molecular formulas. Okay, so we're going to start off with the naming first. I know we normally start off with the formula writing first, but the naming is better here. And just like I said a second ago, here's our carbon dioxide, okay? So then down here, we've got our water. So notice we said dihydrogen because there's two hydrogens here, and then there's only one oxygen. So we're going to use that mono here, okay? Then here we've got phosphorus and we've got three chlorines. Okay, so just phosphorus and then trichloride. Now, one thing to notice, do you guys notice how we're still adding the IDEs to the suffixes here? Like, so that second element's still getting IDE. The only thing that's new is we're adding these prefixes. And then this last example is diphosphorus, because there's two phosphoruses, and then tetroxide is a better way to say that. So a couple of things I just want to point out here, okay, is notice that there's no prefix here, like no prefix, okay? And you're like, well, I thought we were supposed to use prefixes. We are going to use prefixes, but do you see how like there was only one carbon, so we didn't use a prefix? Same thing here, no prefix, okay? So if you only have one element in the first element only has one atom, let me say that better, then you're not going to use a prefix. But even if you only have one atom for the second element, we would still use mono. So that's kind of like a little exception you're going to have to look at. And then over here, if you look at this one, you might have thought to write this one as monoxide if you just use the prefixes like we do. Do you see how we're dropping one of those, one of the O's there? And the same thing over here for tetroxide. I think I said tetraoxide, and sometimes I still do, but you might have thought that this should be tetraoxide. But notice how that, just like we dropped this O over here, this A gets dropped over here. So in most elements, if you have more than one vowel next to each other, you're going to go ahead and cancel out at least one of those vowels. And our only exception, though, is iodine. They like all the vowels when you're talking about iodine. So just like we've been doing, go ahead, pause the video, solve these problems, come back and check the answer. Okay, so for on this one, when we look here, notice I've got four, so I'm going to use tetra and then phosphorus. Again, notice how the first element's name stays the same. We didn't change it at all. Then I've got three sulfurs, so I'm going to use tri, But then we added the sulfide here, just as a reminder. We're going to call this one tetraphosphorus trisulfide. Here we've got carbon monoxide. You've probably seen this before. Remember, we're not going to put a no prefix if there's only one atom, and you can see that there is only one atom here. But even though there's only one atom of the second element, we still do add the mon to it. Then here we have methane, which is more specifically called carbon tetrahydride. So notice that there's 4 hydrogens here. And then this is kind of an odd one for some kids. Notice how we say like hydrogen is like hydride. So it's like hydrogen, we just add the IDE to the end. And then finally over here, we've got 2 chlorines. We've got 7 oxygens. So I'm going to say dichlorine hept oxide. So 2 chlorines heptoxide. Okay. And then this was like the exception that I was mentioning before was iodine. So like let's say you had carbon tetraiodide, so Ci4. So we would call it tetraiodide, and we would keep all of those vowels in the middle there. Okay. But if it was like tetroxide, okay, you can kind of hear that I want to say tetraoxide, but that A gets left out of it. Okay, the beautiful thing about writing molecular formulas is that you just have to follow the name. Like there's no balancing of charges, and I think this is where kids get the most excited from. Okay, so if we look here, we've got carbon. Is there a prefix there? Nope. So that means we're only going to have 1 carbon. We look at tetrachloride, so it says chloride, so I know it's going to be the element chlorine, and then I need 4 of those. Boom. Then here I've got dinitrogen. So this time I do have a prefix and it's di. So I know that I'm going to need 2 nitrogens, so N2. And then pentoxide, so I know it's oxygen and I'm going to need 5 of them. Okay, and we're almost there. So you guys go ahead, take a second, write the chemical formulas down for these. Obviously pause the video, write the formulas down, come back and check your answers. Okay, so if we look at this one, there's no prefix, so I'm just going to have 1 silicon. And then here, dioxide would give me 2 oxygen. Here, again, no prefix, so just 1 phosphorus. Trichloride, we saw that before, so we'd have 3 chlorines. This one is diboron, so I'm going to need boron, and I'm going to need 2 of them because it says 2. And then monosilicide, I don't know, that one seems kind of fun to say, but it just means 1 silicon, so you can see that that's what we wrote there. And then nitrogen trihydride, we have our 1 nitrogen. Again, there's no prefix there. And then tri means 3, and then hydride means hydrogen. And then you guys, this is the last slide in our video. And so the idea is we're going to be getting worksheets that are going to have both ionic and molecular compounds on there. So remember, there are 2 different ways of like naming the compounds and writing the formulas. So the first thing we need to ask ourselves is if the compound is ionic or molecular. If it's ionic, it's going to have a metal and a nonmetal. And if it's going to be molecular, it's all nonmetals. Okay. And then you're just going to name or write the formula the way that we saw on the previous rules. So if we look at this first one, I've got sulfur and I've got chlorine here. And so sulfur and chlorine are both nonmetals. So I know that this is going to be a molecular compound. And sometimes it does help to write that down next to you so you can remember. So the idea is if we look here, we're just going to see 1 sulfur. And then notice that we see 6 chlorines. And so the prefix for 6 is hexa. And then I'm going to say chloride, and hopefully I can write small enough here. So hexachloride. If we look here at this one is silver, okay, and then nitrate. So silver is a metal, so I know that this is going to be an ionic compound, but it's only silver is a metal that only has 1 charge to it. So we don't have to use a Roman numeral, so I'm going to say that this is ionic. And then this would be silver, and then nitrate. And then finally, if we look at this last one, we've got potassium and we've got sulfate. Again, potassium is going to be a metal. You can see that in the first column on your periodic table. So we know that this one is going to be an ionic compound. And then, so for this one, potassium sulfate. Now we need to write some formulas over here. So when we look at the formulas, we're going to see that we've got lead and then it has the Roman numeral here. So first off, we know that this is going to be an ionic compound because lead is a metal. And then this Roman numeral is going to tell me the charge on this lead. Okay, so I'm going to be Pb 2 plus, and then it's going to be bonding with nitrate, which is 1 minus. So when we write this formula, it's going to be Pb, and then I only need 1 lead, but I am going to need 2 nitrates here. And so that would be my formula. Then when I look here, I'm going to see bromine, pentaiodide, and look, we've got all those vowels here together. And so we notice that bromine and iodine are both nonmetals, so it's going to be molecular. But we also can kind of check out that there's a prefix here, so that's another clue that it's a molecular compound. So there's no prefix here, so it's just going to be 1 bromine. And then pentaiodide means iodine here, okay? And then I'm going to have 5 of them. And then finally down here, you guys, we've got calcium nitride. Calcium is going to be a metal. So I know that this, oops, I lied. It's not a molecular compound. I think I was thinking metal. So it's going to be an ionic compound here. And so again, we just need to balance out those charges. And so when we do, this should be Ca2, oops, I lied, Ca3, Ca3 in 2. Okay, guys, I hope that these videos have been helpful. Make sure you guys ask any questions that you have in class. See you soon.